So here's the idea. And that idea belongs to Cramer, or at least people say it belongs to Cramer. And the whole thing is called Cramer's rule. So that's the name you can find in linear algebra. And I'll show you a picture right there. I use different colors here, but that's okay. So what I want now is to think about the ratio of this length to that given length. And what I claim is that you see what's going on there? What I claim is that this ratio of length to the length is equal to the ratio of areas of these two parallelograms. Area of this large pink parallelogram related to the area of the red parallelogram. Okay, that's what it is. And then my claim is that if you keep track of this pink parallelogram, its area is exactly the same as the area of the parallelogram on the given vector B and the given vector W. Oh, not B, but that's my W. Okay? So that's the whole idea geometrically. The ratio here, that x, unknown x, is equal to the ratio of these two areas. One area is parallelogram on these two given vectors. The other area is parallelogram on these two given vectors. That's it. That's the answer. X equals the ratio of two areas. Now, what it means algebraically is simply that x is equal to area of what? So the ratio of that pink parallelogram, right? It should be the area on V and W divided by the area on that red parallelogram, the area on V and U. Now, can we compute that quickly? Well, sure we can. For the area of V and W, we take that V, that W, put them together in 2 by 2 matrix. Now I'm speaking linear algebra language, right? We are making that matrix -3, 4, 7, 1. That's the area. I will have to put together V and U. And notice V and U, not U and V. And so we keep track of the order. So I put V first, -3, 4, and then U, 2, 5. And then I can compute those. So the numerator is -3, -28. The denominator is -15, -8. So that is -31 divided by -23. So it is 31 over 23. That's x. Now you can notice at this point that at the algebra level, if you took the algebra course, it is actually not taught this way, that when you solve the system, you can find the variable you want. What you can do is you can express one variable using the others, substitute, express, substitute, substitute. And it's a long process that, well, it's about the process. It's not about the formula. So there is no formula usually taught about linear algebra, about solving system of equations. So this way you get a formula. Well, it's a big question whether a formula is better than a process. I'm not going to address that. I'm not saying that this is the best method ever. Maybe it's not. But it is a method inspired by geometry. This is one of my favorite applications of this idea that 2x2 determinant is the area of parallelogram.